welcome to the session. And my topic today is Industry 4.0 and the future of work, skills and competences for the next generation. I think I'm the last speaker of the session. Oh my God. Okay. Yeah. I think I'm the last speaker of this entire program, and you might have already heard so much about Industry 4.0 and the definitions, the revolutions, and everything. But it's just a brief intro, and I think most of the points would be repeating. But I tried to give another perspective from my point of view. Okay, starting with. The Industry 4.0, as we all know, the first industrial revolution, it started in the early 1800s, where the invention of steam engine reduced the industrial reliance on animal and human labor. Before, animals were used for transportation and even for industrial operations. And with the mechanization and the steam power, steam engines, a new age of manufacturing and precision engineering has started. And that was early 1800s, the start of the first industrial revolution. And then the second industrial revolution happened in the 1900s, where the assembly line, the mass production processes, many of which are still in use. And then in the mid 20th century, the third industrial revolution started. The computers hit the scene. So the early development of factory automation, robotics, everything started in the mid 20th century. And the fourth industrial revolution, where we are today, manufacturing is increasingly powered by information, real-time data, around the clock. AI is at the heart of the fourth industrial revolution. It is not characterized by a single technology. It is defined by the seamless integration of a number of systems, tools, and innovations. So when we come to the definition of the Industry 4.0, it is the integration of intelligent digital technologies into manufacturing and industrial processes. It encompasses a set of technologies including AI, IoT networks, big data, robotics, automation. It allows for smart manufacturing and the creation of intelligent factories. It aims to enhance productivity, efficiency, flexibility, while enabling more intelligent decision making and customization, and especially in the supply chain operations. I'm moving a little fast because this is just an introduction. Okay, the general definition of Industry 4.0 is the rise of digital industrial technology. This Industry 4.0 transformations allows us to work alongside machines in new, highly productive ways. Sorry. These technologies revolutionize the automation, monitoring, and analysis of supply chains through smart technology. This has reinvented how businesses design, manufacture, and distribute their products. Technologies such as industrial IoT, cloud connectivity, artificial intelligence, machine learning are now deeply woven into the manufacturing processes. The unified and integrated approach to manufacturing results in products, factories, and assets that are connected and intelligent. Developing symbiotic, rewarding collaborations between the people, technology. So with this, the accuracy and speed of 4.0 tools come together to get us a win-win scenario. This more efficient and productive manufacturing operations sorry. So our workforce is relieved of a lot of mundane and repetitive tasks, giving them the opportunity to collaborate and learn and get better equipped themselves with the evolving technologies so that they are ready for future of work. So next, coming to the Industry 4.0 technologies. Okay, this is Industry 4.0 is built on 9 technology pillars. Okay, they are this big data and AI analytics, horizontal and vertical integration, cloud computing, augmented reality, industrial IoT, additive manufacturing, 3D printing, autonomous robots, simulation of digital twins, cybersecurity. And these innovations bridge the physical and digital worlds and make smart and autonomous systems possible. So let us see what do these systems do. The first one being the big data. It is collected from wide range of sources, assets, equipment, wherever the data is possible, we are collecting that data. It is extended outside the factory floor into other areas of the businesses and the world, be it customer feedback, reviews, experience, and it includes everything from reviews, market trends, and informs R&D to design weather and traffic apps that help ensure smoother logistics. And when it comes to AI analytics, it is powered by artificial intelligence and machine learning, and these are applied to the data in real time. Insights are leveraged to improve decision making and automation in every area of manufacturing and supply chain management. The second one, coming to horizontal and vertical integration, with horizontal integration, processes are tightly integrated at the field level on the production floor across multiple production facilities and across the entire supply chain. And with vertical integration, all the layers of an organization are tied together and data flows freely from the shop floor to the top floor and back down again. So top-down approach and bottom-up approach. In other words, production is tightly integrated with business processes like R&D, quality assurance, sales and marketing, and all other departments, reducing data and knowledge silos and streamlining operations. So this actually enhances the efficiency, productivity, and cost optimization and faster delivery. Next, coming to cloud computing. This is the great enabler of Industry 4.0 and digital transformation, because what cloud computing gives is the access to hold so much of data, to store it, to analyze. We need so much of space, and this cloud computing made it possible. So this provides the foundation for most advanced technologies, from AI, machine learning to IoT integration, and gives businesses the means to innovate. The data that fuels Industry 4.0 technologies resides in this cloud, and the cyber physical systems at the core of Industry 4.0 use the cloud to communicate and coordinate in real time. So this cloud computing, this cloud makes it accessible to access all the data from any part of the world. So this is the biggest advantage of this cloud computing. Next comes augmented reality. Augmented reality overlays digital content onto a real environment. And with an augmented reality system, employees use smart glasses or mobile devices to visualize real-time IoT data, digitalized parts, repair or assembly instructions, training content, and more, all while looking at a physical thing like a piece of equipment or a paper. AR is still emerging but has major implications for maintenance, service, and quality assurance, as well as technician training and safety. Especially augmented reality has a lot of applications in terms of all these mining industries, underground piping, even in construction, and in the crisis management. Augmented reality, when used, I think this would actually be a very big boon to the disaster management processes. Next comes the industrial Internet of Things. This is so central to Industry 4.0 that we use industrial IoT and Industry 4.0 very interchangeably. The most physical things in Industry 4.0, devices, robots, machinery, equipment, sensors, products, these use sensors and RFID tags to provide real-time data about their condition, performance, or location. And how this data is used. This data is used for predictions, preventive failures, smoother supply chains, rapidly design and modify products, to stay up to date, prevent equipment downtime, stay on top of customer preferences, track products and inventory, and much more. This has unlimited applications. Moving on, the next is additive manufacturing or 3D printing. This was initially used as rapid prototyping tool, but now offers a broader range of applications, from mass customization to distributed manufacturing. Parts and products can be stored as design files in virtual inventories and printed on demand at the point of need, reducing both costs and the need for off-site and offshore manufacturing. And every year, the applications of additive manufacturing and 3D printing are growing more variedly, increasingly including base filaments such as metals, high performance polymers, ceramics, even biomaterials. And now the 3D printing has made even construction and in the civil domain. I have seen recently they've constructed villas using 3D printing. So this is sorry, this is growing very fast, rapidly, and I think this has a great potential to change the real estate scenario tomorrow. Moving on, the next is autonomous robots. Autonomous robots are programmed to perform tasks with minimal human intervention. Vary greatly in size and function. It can be used for various applications, from inventory scanning drones to autonomous mobile robots for pick and place operations. The one of the biggest example is Amazon warehouse, Amazon services, that is completely operated by these autonomous robots. There is no human intervention. The complete the order book of the Amazon's execution of all those orders is done by these robots, and that is a very beautiful scene to watch and appreciate the advancement of Industry 4.0. So, equipped with cutting edge software, AI sensors, and machine vision, these robots are capable of performing difficult and delicate tasks. It can recognize, analyze, and act on information they receive from their surroundings. The next comes simulation digital twins. Digital twin is a virtual simulation of a real world machine, product, process, or system. Sorry. Based on IoT sensor data. It allows businesses to better understand, analyze, and improve the performance and maintenance of industrial systems and products. Sorry. An asset operator, for example, can use a digital twin to identify a specific malfunctioning part, predict potential issues, and improve uptime. I have worked on one digital twin, and I would be sharing my case study as well in the later slides. The next comes cybersecurity. With all the Industry 4.0 tools, I think the critical thing is about the security of all the information and the application part. So the cybersecurity plays a very important role in this, and with this with the increased connectivity and use of big data, effective cyber security is paramount. By implementing a trust architecture and technologies like machine learning and blockchain, companies can automate threat detection, prevention, and response. Cybersecurity can minimize the risk of data breaches and production delays across their networks. I think one of the very good example would be our digital banking system, our UPIs, how the cyber security thing and how it has made banking possible to a digital banking possible to every Indian. So that is a very good example. Moving on. Manufacturing 4.0 solutions in action. The digital transformation associated with the Industry 4.0 brings about both cultural and operational evolution. By unifying and connecting people, data, assets, it creates an almost limitless range of potential optimizations. Here are some few examples of how Industry 4.0 solutions are improving the sustainability, efficiency, visibility in manufacturing and supply chains. So coming to the collaborative design platforms, Industry 4.0 supports R&D teams, the designers, and all the stakeholders from various organizations. They can access and contribute to design data and insights. This provides an open approach for cross-functional collaboration, idea sharing, and knowledge exchange, which leads to a faster development of innovative customer-centric products. Next comes the predictive maintenance. By integrating IoT sensors and data analytics, Manufacturing businesses can monitor equipment health in real time, and this is one of the biggest advantage. And now you can see in cars, this is very common to see where everything is monitored and everything is seen on the screen. So predictive maintenance algorithms identify potential failures before they occur, allowing you to implement proactive processes which can reduce downtime and prevent failures. Quality control and defect detection. Leveraging these devices and machine learning algorithms, real-time data from production lines can be collected, and this can be used to continuously monitor and manufacture so that you can reduce the failures, you can detect the anomalies, and quality issues can be identified. Corrective action can be taken faster, and you can actually improve your processes. Then comes the circular economy practices. Industry 4.0 solutions supports the implementation of circular economies, focusing on reducing waste and maximizing the reuse, refurbishment, and recycling of materials. Actually, this is very, very critical uh, to cater to the pollution, climatic change, and sustainability. And scrap disposal, waste management, circular economy practices contribute a lot to these problems. So by utilizing big data analytics and IoT networks, we can track product life cycles, implement reverse logistics for product returns, and optimize the recovery of valuable resources. And what's more, actually, AI powered advanced analytics can also help your product designers to develop products right from drawing board to build more sustainable, waste fewer resources, and be more easily recycled and repurposed, making a sustainable supply chain. Next comes the supply chain optimization. This supports the end-to-end visibility across a global supply chain. So with real-time data, optimization of logistics, balance supply and demand, improves order fulfillment, and enhances overall supply chain and manufacturing efficiency. Next comes the agile manufacturing. So agile manufacturing allows to gather and analyze real-time customer insights and feedback from sources like social media. We can leverage data to identify consumer preferences, pain points, and emerging trends, and based on this, quickly develop products that better align with the market trends, improving satisfaction and loyalty and driving innovation. And next comes the carbon footprint monitoring and optimization. And I think this is the key for a better tomorrow. So Industry 4.0 technologies facilitate the collection and analysis of real-time data on energy consumption, transportation emissions, and other factors contributing to a company's carbon footprint. By accurately measuring all these parameters and monitoring them, strategies to reduce overall carbon footprint can be developed, helping to meet increasingly ambitious sustainability goals. And this is very, very critical for any manufacturing facility, any industry, and uh, each and every individual also, because it is our responsibility to create a better tomorrow for the future generations. And I think the Industry 4.0 solutions should provide and should lead us to uh, cater to a better tomorrow. So moving on, I would be providing some two case studies from my research. Uh, excuse me. So we have worked on this simulation-based digital twin for real-time monitoring of motors. So actually, BHL R&D, we have developed the electric vehicle motor, which was to be used in the electric buses. So for the during the development of the motors, generally we will not be able to see what is happening within the motor. When we test the motor, we will have the what we test is uh, apart from the electrical parameters, what is the output it is giving, and the heat, the thermal management of the motor is very critical to its operation. So the thermal management is done by just monitoring the temperatures of the stator windings inside the motor at maybe 6 locations, three each side. So 6 locations using resistant temperature detectors, that is RTDs. And generally, if because that is very important, because the class of insulation is decided based on that, and if the temperature goes beyond that, the windings might get short, and there is a chance of the windings getting burnt and overall motor failure. And generally, on a conservative side, the motors are designed at a conservative side, and for power plant equipment and other operations, motors are sorry, motors are generally loaded to its rated load and continuously operated at that load. But when it comes to electric vehicle motors, the load is continuously changing. So we do not know what happens inside. And the irony is, it's not that the place where we are measuring the temperature, that could be a hotspot, or that could not be a hotspot. There could be a spot where the temperatures can be even more, where we are not measuring. So generally, for power plant equipment, it is very easy, because we just take a factor of safety and we are safe, and we just do a simulation we do CFD, we carry out CFD simulations for the rated load, that's the highest load, and then because it's going to be on a conservative side only, we just go with the manufacturing and then deliver the product. But when it comes to electric vehicle motors, it's not that. It's not the scenario. So the thing is, we need to know what's happening completely inside the motor, and to have a 3D perspective inside the motor, because there are rotating equipments as well as stationary equipments, stationary parts. Rotating parts, we cannot measure the temperatures what are there in the rotor, and so only stationary parts we can measure, and that too we cannot measure throughout 3D. We cannot put so many sensors. So what we have decided, this was way back in 2017 to 2019, where we have carried out this project. So we have created a digital twin based on the CFD simulations, and we have done for a traction motor, developed using computational fluid dynamics and artificial neural networks. So the traction motor has been simulated for different load conditions, such as 25% load, 50% load, 75% load, 100% load, and 125% load using CFD. So these 5 cases were simulated using CFD. And from this CFD data generated, a digital twin of the motor was developed using ANN and deep learning methods. So condition monitoring of traction motors was done by monitoring the live temperatures across the motor for preventing the insulation failures. Later, we have validated that using the test data also. So the virtualization through the life cycle of a motor. So first what we have done is virtual system design, and then a digital twin construction and virtual integration. So generally what we do, we design, we construct, and then we operate. Okay. But what happens is, now at all conditions, so okay, let me explain how we have done. So based on these 5 conditions, we have collected. Okay, I'll go to the next slide. Yes. See, you can see the picture at the left-hand side. This is the picture of the traction motor, and what you can see is all these slices which you are seeing are the data for a particular condition, particular load. You are seeing the temperature contours, 3D temperature contours in all the planes. Okay, this, for example, this is on the XZ plane, and it is a 3D. So, and in the XZ plane, you are having a contour of all the points across that motor. So the data points which we have created, the data which we have extracted from the CFD for one particular plane is only in hundreds and thousands of points. So what we have done is we have mapped the complete motor inside the complete motor. We have mapped all those points, and we have taken the critical parameters like temperature, pressure, velocity, and we have also taken these contours. So you can see on the top there is a CFD plot and an ANN plot. So the CFD plot, this is the output from the CFD. This is a sectional plane. An XZ plane plot is shown, temperature contour, and we have generated models, machine learning models using artificial neural networks and CNN, deep learning methods, and we have created a model. And finally, the ANN plot predicted is on the right hand side. So initially what we have done is the complete data of all those 5 operating conditions. We have used some 70% of the data to train the model. We have given the CFD data as input. ANN model, we have trained the ANN model, and we have validated that ANN model. And then in the deployment, we have given the motor real-time data. So while it was running, we have deployed this ANN model, and we have asked it to generate a temperature profile. And how it was generating, we have tested using the sensors. In-house, when on the shop floor it was happening, we have tested at various conditions what were the temperatures predicted by the ANN model, and what were the testing results. So like this, we have generated a digital twin for a motor. So the next generation digital twin motor is constructed prior to and in parallel with the physical construction, enabling better system designs, more efficient system integration and commissioning, and improved safety and performance in operation. The use of simulation tools such as CFD in conjugation with ANN is the novelty of this digital twin developed by BHL. So this was one of our project. Coming to another case study, this is a prediction of boiler header subsystem temperatures for flexible power plant operations using machine learning techniques. So see there on the right hand side, you can see a power plant. Here, what happens in a power plant is you'll have a boiler. It is a coal-fired boiler. So what happens is you give input as water, and the steam is generated. The steam drives the turbine, and turbine drives the generator, and electricity is produced. So as you all know, this is the normal functioning of a power plant. But you can see the demand. Generally, a power plant operation is done if for suppose a power plant is of 150 megawatt power plant, it operates at 150 megawatt continuously, irrespective of the load. But as we all know, the load cycle changes throughout the day. Here on the left hand side, you can see in a 24 hours cycle, the load, you can see that the load is not uniform. So there are ups and downs. And now with renewable energy connecting to the grid, the demand for production of power from the thermal power plants is not constant. It's not a straight line. So now there is a need for this flexible operation. So in this flexible operation, what happens is the plant does not run on full load. You can see the graph. It might run on 50% load. It might run on 75% load. It can run on full load. And when the power plant has some failures and there is a downtime, it can run on no load also. And why is this flexible operation a tricky thing to a power plant? Because the temperatures at which the power plant operates, the thermal efficiency, that all depends on at what temperature the steam is produced and how the steam is produced. And the failures actually depend upon the thermal stresses, because the materials has to withstand the rapid cooling and the rapid heating, and due to this there are a lot of thermal stresses induced, fatigue induced, and due to this a lot of cracks can happen and there could be a lot of failures. And the most critical would be, because the furnace, the heating, the combustion happens in the boiler headers are the most critical for these thermal failures. So what you can see that the boiler tubes on the bottom right hand corner. Okay, so this project was to predict, excuse me, to predict the boiler header temperatures based on real time data from the operating power plant. So we have taken data from the power plant at various loads when it was operating at various loads. The data was collected, and that data we have, with using that data, we have used supervised machine learning models were developed, and a predictive model was developed using various machine learning models. The developed models can be deployed at various power plants to predict the mean wall temperatures of the boiler tubes, which can be used to predict the life of header tubes in real time. So we have actually we have generated machine learning model. We have tested, means a lot of machine learning algorithms are there. So we have tried and tested, trained the models, and based on that, we have selected one model and deployed it so that for the future, uh, based on the IMW temperatures, we were able to proactively take some steps how to operate the power plant, at least boiler, how to do it. So this was one of the thing where we have used artificial intelligence and machine learning for predicting failures. So these are some real-time examples, uh, and these are the two cases which I have put in our thing. Apart from this, I would like to uh, state some more projects where actually we are right now doing some research upon. We are actually carrying out uh, project on advanced ultra supercritical projects where high spin test rigs uh, and rotors are being tested, and for that we have established telemetry systems, because because till now there is no AUSC uh, power plant established in India. So for that, because it operates at high temperature and very high pressures, uh, we need to test it for all operating conditions. And when the steam turbines and the generators at high speeds at that RPM, uh, we need to collect so much of data, and we need to actually predict the life of the equipment also. Generally, a power plant life would be more than 30 years. So for an AAC plant, when we are tendering, when we are actually giving a price bid, we need to actually calculate the life of the machine, life of the power plant also. So for that, actually we are using telemetry, and now so much of testing is going on, and we are using telemetry, this IoT sensors, we are using this real-time data and all this artificial intelligence and machine learning models for our research to go ahead. And I would also like to state we are carrying out strategic projects for military and army, wherein we are developing cooling systems, and we are collecting data, and we are trying to use inculcate this mechanical and as well as artificial intelligence and machine learning models to predict failures, and also condition monitor all the systems. So these are some of the examples where we are working on. So what's next? Till now we have, because my topic is on future of Industry 4.0 skill and competencies. So what's next? So till now we have seen Industry 4.0, where cyber physical systems we are using. Now it is about Industry 5.0, where mass customization and cyber physical cognitive systems are being used. That means we will be using all the cyber physical systems in association with the human intervention. That Midas touch is required for us to do that mass customization. So before it was Industry 4.0, now it is in the Industry 5.0. That's the future. And from now on, it will not take so much of time. Like Industry 1.0 to 2.0, it took some 100 years, then some 50 years, 70 years. Now it's not like that. Industry 4.0 to 5.0 took some 10 years, and now it would be rapidly changing. So I think it's apt to say that Industry X.0, where we are going to be. And I think if next year we are meeting, I do not know at what industrial revolution we are in. So we have to embrace the renew digital reinvention of industry. And I think from now on I would be calling Industry X.0, and I think that's the future. Moving on, the three pillars of the Industry 5.0 are the people centricity. People are at the core of the processes. It's at the center of the process and decision making, not mere cogs in some vast machine. Like it's not like robots are replacing humans. It's not like that. And I think people centricity, people are the most important in the Industry 5.0. Even uh, now, if you can see, where there is we are using this chat GPT and all, you need people to give the right kind of command, and to extract the right kind of experience from those machines. So it is going to be a people centric, and it is going to be the next pillar is the resilience, being able to change quickly to stay ahead of the curve and adapt to changing market dynamics. And the market is changing so dynamically, and I think take any sector, transportation, health. I think healthcare, health tech is it's going to grow like anything. And even transportation, and think and the kind of experiences which we are going to have. Uh, the next would be sustainability, where new skills for workers and circular processes to leave a better world for future generations. I think this is the most important, because whatever it is, this is actually going to drive all the businesses, all the corporates, and I think all are mankind with a sense of purpose. This is going to drive. So sustainability is the buzzword. It's not only the buzzword. I think this is the biggest responsibility on all of us. So till now we have spoken about industry. Now it is from industry to society. You can see society 1.0 was hunter-gatherer society. Next comes the agricultural society, and then industrial society started, because this industrial revolution started. Now uh, that industrial society changed into information society, and now we are heading towards a super smart society. I think you have all experienced, at least in our urban areas, you have seen smart gardening systems, smart apartment systems, and smart traffic systems. Everything, like everything are maintained by IoT sensors. It's like you can seeing the yes, cleaning solutions, where you have got those robots to clean your house, and based on the intensity of light, the lights can be automatically operated. Based on, I think even for agriculture there is going to be smart agricultural society also, and that's part of super smart society. So this is where we are going to be in future. So from industry to society, excuse me. So we are going to be sustainable, lead action on sustainability and respect planetary boundaries, and be resilient with flexible and adaptable technologies. And we are going to be human centric, promote talents, diversity, and empowerment. This industry 5.0 is going to lead to a society 5.0, ensuring high quality lives full of comfort and vitality. Super smart merge between cyberspace and physical space with 5G, big data, artificial intelligence, and provide the necessary goods and services for individual people at the necessary level when needed. So the benefits would be Industry 5.0 is a solution provider for people and for our planet when used very wisely. Okay, improved safety and well-being, reduced cost, empowered workers, competitive industry by attracting best talent, adapted training for evolving skills, competitive edge in new markets. So the opportunities, limitations, and future research. The opportunities would be, I think, we can now imagine, our imagination has no bounds now, and whatever previously when we used to imagine, it's like, this cannot be done, but now it's like you imagine and you can actually put it into action. We are so rapidly growing. So some of the opportunities would be binaural beats, smart infrastructure, smart clothing, clean energy, intelligent transportation. And some of the limitations are information security, human machine collaboration, adjustability, high skilled workers, digital forensics. I think these limitations also provide us opportunities, like how to tackle all these things. So, our future research would be hyper intelligent networking, blockchain, ultimate security and trust, quantum computing. So I think these would be our future areas of research. Moving on, the highlights of Industry 5.0 when compared to Industry 4.0. Industry 4.0 focused on connecting machines, how to connect all those sensors into your processes, and how to get that efficient output. But Industry 5.0 focuses on delivering customer experience. I would like to give an example here. I think, for example, you can take this Amazon app or Amazon Music app, any music app. Before we used to use tape recorders, then MP3 has come, iPod has come. So we had to put our songs into that and then listen. Okay, next came an app, a music app, where you have so many songs, and then it is for your experience. You can create playlists, and now it has moved a step further, where you are listening to a song, and based on your liking, the suggestions are also given based on the music, the kind of music you're listening, romantic music or pop music or rock music, English, in which language you are listening, and based on the artist you are listening, and how many times you have listened to it. So they are providing enhanced customer experience. So Industry 5.0 is focused on that. And Industry 4.0 catered to mass customization. We focused upon mass production and giving those products to everyone. But Industry 5.0 focuses on hyper customization. It's like you can actually give how many ever attributes you want, and you can customize it to your liking, and it has no leaps, it has no bounds at all. So Industry 5.0 focuses on hyper customization. Industry 4.0 focused on intelligent supply chain, but Industry 5.0 is focused on responsive and distributed supply chain. So collaboration, end-to-end visibility, these are all very, very important for actually giving those deliverables which Industry 5.0 is targeting upon. Industry 4.0 was upon smart products, and Industry 5.0 is about experienced, activated, interactive products. So Alexa or even intelligent fans, smart cookers, your daily life, you can experience all these interactive products around you, and I think this is going to be evolved even more. And coming to the next point, Industry 4.0, it was manpower distanced from factories, but Industry 5.0 we are going to see a return of manpower to factories. So this is going to happen because human intervention is the key for driving any industrial revolution, and that has been it is now accepted and realized. So what's the opportunity? Uh, from the first industrial revolution to the present industrial revolution, the mass personalization and personalization, and we have no bounds to our wants and fancies, and we can use our creativity and technology to cater to any kind of customizations and personalizations. So this is a very good opportunity to all of us, and to for the next generations as well. So I would like to present another perspective of COVID-19, how COVID-19 has changed industry 4.0, because I think one positive side, rather I do not want to use it, but one positive aspect of COVID-19 was the implementation of industry 4.0. uh, it has made it a necessity rather than an opportunity. It's like it has made it very essential that we use industry 4.0 solutions, and that has made the implementation of these tools faster. So it has acted not only as a catalyst, it has also we have used this opportunity as a stress test also. So these are some of the key impacts of COVID-19 on Industry 4.0. Uh, acceleration of adoption, where the scaling of digital technologies happened the most, the rapid growth has been seen uh, during this time. Operation resilience, resilient and flexible systems actually fared really well, and they have withered the timeline of COVID-19, and they have come up with good solutions and nice business profits also. And focus on absorptive capacity, leveraging external knowledge, how much we can collaborate and access and implement to deliver. And then shift in up priorities, agility and flexibility over productivity and cost optimization. And COVID-19 actually taught us how agile and flexible we need to be. Supply chain resilience, collaboration and visibility. This was the key for supply chain resilience, and which enhanced the logistics and the distributed logistics during that time. A digital transformation, making the world more digital. I think COVID-19 has changed the entire perspective of social media, where we were using it as an entertainment, and now it has become a channel to not only for information but also for generation of money. And that a business perspective has come on to uh, the social media as well. This is one of the biggest change. And then sustainable manufacturing, the circular economy, and COVID-19 has taught us how to use wisely waste management, because we had so many issues during that time. And I think circular economy, uh, the sustainable manufacturing, they have brought in the circular economy into our manufacturing processes. And new challenges such as workforce, the remote working. I think remote working wouldn't be possible if such an thing has not happened. And this has retained so much of talent, and it has provided so many solutions. I think drones was one of a key thing. And in terms of health tech, I think every challenge had so many solutions, and this has provided a very big opportunity for implementation of Industry 4.0 solutions. COVID-19 actually has taught us to adapt to the new normal, as you all know. This has significantly accelerated the adoption of Industry 4.0 technologies as companies sought ways to maintain operations, manage disruptions, and adapt to the new normal. So, digital transformation was a necessity and not a luxury for businesses. Uh, and because social distancing norms were there, monitoring operations aided by IIoT, Industrial Internet of Things, was implemented on priority. This enabled resilient and flexible systems that responded to unpredictable market demands, supply chain interruptions, and manpower shortages. As I already explained, agility and flexibility have become the top priorities. Sustainable manufacturing, AI-enabled technologies helped in understanding the virus's biological structure, crucial for vaccine development. And IIoT-enabled smartphones aided in contact tracing and syndromic mapping. As you all know, AI helped us so much to navigate out of COVID-19 and provide sustainable solutions. So, highlighted the importance of resilient supply chains and technologies, aiding collaboration and visibility across them. Organizations that had adopted these technologies, empowering Industry 4.0, were better positions to fight the crisis. And this led to large scale training and adoption of new technologies. So, what now? Uh, so, as how are we making our future generations ready? So, because this is for educational institution, I try to put a perspective from the education point of view. So, future proofing education, preparing students for Industry X.0. So, equipping the next generation with the skills to thrive in a human and a machine world. So, when I passed out in 2010, so when I passed out, I am a mechanical engineer by qualification, but I passed out maybe 15 years back. But you can see my work profile. I worked in electrical machines manufacturing and then moved to research, wherein I do computational. I did computational fluid dynamics on electrical machines and done my and then use artificial intelligence and machine learning. I have learned because this is not my field. Electrical engineering was not my field, so then adapted AI/ML to give solutions. So this is just an example. So I don't think tomorrow there would be any boundaries to your qualifications. You will not be called a, mechanical, electrical, CSC engineer. I think we should not be discriminated based on those boundaries. I think we all now all are engineers and professionals. We need to make such professionals ready for tomorrow. So the dawn of Industry 5.0, it's a new era. So what are the prerequisites and what are really required? From that point of view, this would be the last segment of my presentation. So cultivate critical thinking, problem solving and creativity to tackle novel challenges in the evolving landscape. So critical thinking is really very, very important. You need to have a clarity and precision, logical reasoning, evidence-based analysis, open-mindedness, intellectual integrity, and problem solving, where you need to have a clear structure about what is the root cause, what are the potential solutions, and how do we plan to deploy, and whether that solution is after whether that solution is going to work or not, and creativity. And the world is growing, the world is changing so dynamically that we need to be on par with all these emerging trends. And I think change is the only constant thing, and this change is happening really, really fast. So we need to have a clear and open-mindedness to actually accept all these things, process, and give a solution to it. So as professionals, as teachers, as faculties, we need to cultivate this critical thinking, problem solving, this dynamism and creativity in the students. So from a student point of view, I'm going to talk about. So, encourage holistic problem solving by promoting collaboration between diverse fields, including integrating arts and humanities into STEM. So, it's not about mechanical, electrical, and civil, CSE, AI, cyber security. It's not only in the technological field, as well as arts, humanities, and healthcare. I think healthcare is at the tip of the iceberg. Whatever we are going to do, that technology will be having some application in your healthcare, and that would be that would be enhancing the life of the human. So we need to be very open to accept. Now it's not like art stream, humanity stream, management, science, technology. It's not. These are all interwoven and deeply woven now. So equip students with the skills to analyze data and navigate the information-rich environment. Coding knowledge is now essential. Master data analysis, essential for navigating the complexities of the modern digital economy across all industries. And as teachers and as faculties, uh, coming from core branches at least, I would say coding knowledge is now essential in the sense you don't need to learn coding line by line and understand what is going to happen. Okay, because I'm a core person, core from a core field. What coding knowledge is now essential in the sense you should be able to decipher, interpret what it is going to do. Because we have so many AI tools, so many AI assistants that if you can rightly communicate with the tool, that tool can give you a code. It can provide an application. It can provide a solution. But what is important is to understand that idea, to have to interpret it, and have a vision about how it is going to be. So if a student comes to you and they say that this is my idea, and if we are not understanding it, and if we are not relevant, I don't think we would be able to visualize and foresee what is going to happen. So we need to be relevant, and that is the crux of coding knowledge is now essential. Okay, so skills for success, bridging the gap, gain expertise in advanced manufacturing techniques to contribute to innovation and efficiency in production processes, uh, develop empathy and communication skills to enhance human machine interaction and navigate complex social dynamics. And this is the point which I would like to emphasize so much from the industrial point of view, because we see the present generation students lack a lot of empathy and communication skills, uh, and those social dynamics. And I think as teachers and faculties, we have a very big responsibility to inculcate these qualities into the students. And this is not only important to communicate with the professionals or else at their office. This is really important to communicate with the AI tools, because how you communicate with the AI tool gives uh, that determines the output of that AI tool. So we need to have that empathy, we need to have that understanding, and I think that proper emotional uh, quotient has to be there in that particular person to actually use so many things. So you can see the picture there. We are interconnected with so many things. Okay, the world is growing so fast, intertwined with all these things, and to have the clear understanding and to have a clarity in your thinking and to access your critical brain and give solutions at those critical times, I think we need to practice that mindfulness and have a sense of empathy so that we are on the right track to provide solutions to the critical problems. So embrace hands-on learning to emphasize emotional intelligence and foster a passion for continuous growth and adaptation. These are really very important. The next would be cultivating digital fluency. Data analysis. Learn to analyze and interpret data to extract insights and make data-driven decisions in various fields and industries. See, we have a pool of information, pool of data, and a lot of noise in the data. Having data is useless if you do not know what you want to do out of it. See, if there are 10 people and the same data is provided to all the 10 people, I think all 10 of them will see the data in 10 different ways. So they could come out with 10 different solutions or 100 different solutions out of the same data which is being provided. So the data analysis part, so that analytical part is really very, very important, comprehensive, and very much essential for any of the things to actually learn and do. Moving on, next is a cybersecurity. Understand the importance of cybersecurity and best practices to protect sensitive data and systems from potential threats. I think this is a very known fact. Cybersecurity is such a big threat, and digital frauds, ethical hacking, um, and to safeguard and to learn about cybersecurity, the fundamental would be the ethical human values in the first place, and next understand why it is very important to have our data secured, and go about tackling about the potential threats. Moving on, next would be cloud computing. Explore cloud computing concepts and technologies to leverage their potential for scalability, efficiency, collaboration, adaptability. Cloud computing is really important. And next would be coding. Develop coding knowledge to effectively understand and interact with the technology shaping Industry 5.0 innovations. And next would be digital tools. There are so many digital tools. Gain experience with digital tools, platforms, and technologies relevant to their field of study for optimal digital fluency. I think we need to have some amount of digital fluency to stay in trend and move forward. And next comes the power of lifelong learning, staying ahead. So the crux of everything is we need to learn, unlearn, relearn, and keep learning. So that's the essence, and that's the future readiness which is required for students as well as teachers as well as professionals. Anyone, embrace learning opportunities beyond the classroom, as continuous learning will be essential in the fast-paced industry. Continuously seek opportunities to acquire new knowledge, to remain relevant, to enhance skills, to build experiences. And continual learning empowers adaptability, enabling students to navigate the dynamic demands of industry confidently. And I think the two primary takeaways, and I would like to emphasize, is lifelong learning and do it with empathy and kindness. So the strategies for preparing students for Industry 5.0 would be adaptable skills, experiential learning, interdisciplinary learning. I think the kind of approach which we have to give students right now would be adaptable skills. Make them so dynamic. They have to adapt this, because the curriculum before, it was a very strict curriculum, but now it needs to be a wholesome curriculum, a holistic approach curriculum, which also should be a dynamic, in a dynamic form. And experiential learning, it's not only theory now, it's everything is practical. Based on experiences, I think that would actually enhance their learning as well as their empathetic side also. And next would be interdisciplinary learning. Now it's not before it used to be multi-physics. Now it is multi-disciplines and multiple areas. So humanities, arts, health, biology, technology, science, everything are interconnected. And I think those cross-functional uh, teams and cross-functional learning has to be done. And digital literacy is one of the very important thing. Next is emotional intelligence and the joy of lifelong learning. We need to tell students that a degree is not sufficient. It's every day, every day we need to learn something new, because to stay relevant, even for me, to stay relevant, I need to learn all the emerging trends and stay up to date for us to adapt as well as to deliver. So this is that's it from my side. Thank you. Thank you for a very patient listening, and thank you for giving me such a wonderful opportunity to speak on this wonderful topic. Thank you.
Madam, we are so delighted to have you actually, madam.
If you have any questions, I'm open to take.
Yeah, yes, ma'am.
Yeah,
Audience?
first of all, thank you very much, ma'am. Even though you are having a cold and cough, and you have completed the wonderful session, entire content is very much effective with respect to the current scenario and respected to the VUCA world. So thank you very much, ma'am. I am having
Thank you,
one
sir.
question, ma'am, regarding means right now as the world is not still moving on the industry 4.0 completely, even though industry 5.0 been started. So, as per your point of view, how it will be affecting means with compared to the industry 4.0?
Sir, Industry 4.0 has laid the foundation for Industry 5.0, sir. Industry 5.0 was like integrating all these equipments, all these enhancing the products. And what we do with enhancing these products, we are actually customization. We are giving a enhanced experience using Industry 5.0. And I think for you, I would like to give an example, sir. See, before we had televisions, uh, then came OTTs were OTTs are a very good example for Industry 5.0, because the content which is generated and how it is generated. I have, sir, being this generation person also, I have never imagined that on my hand I would be watching so many series, so much of drama, so much of entertainment. I have never imagined that there is so much of scope for entertainment. And it's not only entertainment, it is about how you get business out of it. So you will be shocked to see how much Netflix, Amazon, Hotstar are earning out of this. And because of this, what is happening, at least from the rural background, if we see, we are actually making people digitally literate. So that is one side of one perspective of this. So I think Industry 4.0 has laid the foundation for Industry 5.0, sir, because how you use the sensors, how you use the big data, how you use artificial intelligence and machine learning to have that data, I think that has paved a way for us to have a visionary industry X.0, leading us to industry X.0.
Okay, ma'am. Thank you.
Thank you, sir. So just a minute, sir. Give me a moment. Yes, I think I'm not able to.
Madam, may I come in, ma'am?
Yeah, please, sir.
Yeah. So normally the last session speakers will always have a challenge. I think Madam will agree on it, right? So your presentation on Industry 4.2 and no, the future work was captivating journey to the tomorrow's workforce, and it was really blending the cutting edge technology with the real world insights. I think you will agree the statement what
Yes,
you
sir.
have done
Thank
it.
you, sir.
And with a dynamic mix of visionary foresight. That is what I would like to say, because many of these session trainers, they came and they talked about only the title and topic, but your visionary foresight for not only for academician, and you have included for student and even for industrial professionals. So that in that way, really, I the way in which you presented your entire presentation, and I liked each and every slide. I don't know which artificial intelligence tool you used. I do not know. So
Nice, sir. Oh, thank you, sir. Thank you. Thank you for
and
asking me this question also. Sir, I
yeah.
have used artificial intelligence to give certain answers to my questions, but the slides are made by me completely.
I totally appreciate you, ma'am, because you also belongs to my community. I am a B mechanical, graduate.
Sir, now we are
And
all one, sir.
yeah, that is what at last you said. I will come to the later. Okay. So you were illustrated and you really illuminated rather. Just now you went and switched on the light in your room. Likewise, you illuminated and the essential skills and the competency that is required for students, faculty, and all professionals for next generation of work. I think this you will agree. So,
Yes,
like
sir.
you, I also got cold and cough. So I'll be speaking very slowly. Okay, ma'am. So the entire station felt like a high-speed tour, through a futuristic factory where every station revealed, innovation way to upskill. You are talking about skilling, upskilling, reskilling, but I will add one more word: adapt. So you
Correct, sir.
said skilling, upskilling, reskilling. So in your statement, with your permission, I'm going to add one more word called adapt at the end.
Correct, sir. Correct.
Okay, madam. Yeah. So
Absolutely,
overall,
sir.
your yeah. So overall, your session was like a master class in aligning with human potential with with what I say. We talk about AI, technological progression. So leaving the excitement about the endless opportunity ahead for both faculty, students, and as well as professionals, right? So in that way, I would like to comment to your 45 minutes or a 1 hour session. And if our HOD madam agrees, I would like to comment. I would like to take 2 or 3 more minutes to comment about Madam Srisha's session. May I, ma'am?
Yes, sir. Yes, sir.
Okay. So
Yeah.
and I love animals, and especially I love elephant. So the entire session I could see the right top of madam screen. One elephant was hanging. So
Sir,
this
actually,
immediately.
sir, actually,
Yeah. Tell me, ma'am. Yeah.
Sir, I am now, actually, I would like to identify myself. Whatever is there on the slide, I don't think that is my identity. Now I have a new identity, sir, and I take so much of pride to tell that I am now a new mother to
Oh,
a baby
congratulations.
girl. So
Congratulations.
that elephant is for my daughter who is outside. Okay, she is 8 months old. Uh,
Oh,
so
congratulations, ma'am. Yeah.
thank you so much, sir.
But
Thank you.
this analogy is for you, not for your daughter. With your permission, if you
Yes, sir.
permit, I would like to tell only 5 points.
Okay, sir.
With your permission.
Yeah, yes, sir. Sure, sir.
Okay, madam. Now I'm going to connect your elephant with the artificial intelligence and your topic industry 4.0.
Oh, very nice, sir.
See, since I'm a mechanical engineer, I'm head of robotics. First point I would like to connect the artificial intelligence and the trunk of the elephant. Like, so the elephant trunk is look like multitask tool of a robot in industry 4.0. That is
Right.
how I imagine.
Right.
So this, the elephant trunk could instantly identify and pick up the object with very precision, and it can sort like smart sensors and the state of art factory. That is what I compare the elephant with artificial intelligence sensors. Right, madam. This is point number one. And second one, since elephant is very funny animal, and it normally used to take mud bath, right?
Correct.
So I would like to connect mud bath with our artificial intelligence industry 4.0 system update. See how elephants love their mud bath to protect their skin. Similarly, all machines which are used in industry 4.0, right, in artificial intelligence platform, they must refresh, their cycles.
Correct, sir. System
Otherwise,
updates. System updates.
yes, exactly, madam. System updates, or you can call it as update reboot, or
Correct.
rebooting the system. So
Correct.
this is how I would like to connect mud bath of an elephant and the system updates. Okay, madam. So the third point I would like to know, it is a myth or I do not know. Elephants are having a much higher memory than human being. That is what I studied or I heard through stories. Now I
Higher
am
intellect,
45
sir.
years.
Correct.
Yes,
Yes.
madam. Yeah. So I would like to connect your elephant with your presentation on cloud database, right? So elephants are known for their incredible memory, right? And it can recollect all the data and data points. So likewise, you explained last 1 hour about Industry 4.0, right? With respect to artificial intelligence, right? So if the relevant runs an AI, right, it can recollect all the data from their cloud database. That is what I would like to connect. Memory of an elephant and iCloud database, right, madam? This is third point. And the last before point, uh, comforting alerts. For example, so whenever an elephant, right, it is at a serious attack, and whenever it needs, any help, whenever it want to give some signal to others, right, it will, trumpet. So the entire forest will listen to that sound, right? Might be a call or might be a signal. So likewise, in an industrial IoT alert system, if anything goes wrong in the factory, you kindly imagine. So instead of having a beep beep sound, if you embed elephant trumpeting alert, that might be a funny thing, and it can really activate people to listen, and it will alert all the people on the emergency or evacuation situation. So it look like a natural sound rather beeping alert. So this is the fourth point, and the last point. I would like to connect with the mouse bug analogy. For example, this is a myth. That is what I understand. See, a small bug when it get into the ears of elephant, that will totally distract the entire behavior of the elephant. So likewise, this I read in a comical stories. Likewise, a small bug in an artificial algorithm or a minor sensory error in industry 4.0, it will have a surprisingly a very big reaction how elephant is behaving and losing its control. Even though it is very big in shape and size, it loses its control because of a small bug in its elephant ear. So by looking at your what we call it as that elephant poster, I thought of connecting your AI presentation and your industry 4.0 presentation, connecting with that elephant. I do not know whether is it the right way of
No,
connecting
sir.
an
No,
analogy.
no, no. Sir, it's very, very appreciable, sir. I appreciate you for that, sir, because I think I take it in a very positive way because my presentation has, okay, it is really very creative. Be it my presentation or my elephant, it has triggered such a beautiful creative thought in your brain, and you have shared it with all of us. And thank you so much for such kind words, sir. And the last point, which you told, the fifth point
Bug.
regarding the bug, sir. I
Yes.
think that's why a master is needed for a trained elephant and for AI to deploy I think that's where the human intervention is there. That is where Industry 5.0 is going. So you need to tell all the students that AI is not going to take the jobs of humans. It is not going to replace humans. We are going to work hand in hand with all these emerging trends.
Oh, wonderful, madam. Wonderful, wonderful. Really, I liked your session. But the last one question, I don't know whether it is a personal question or not. In your first slide, under education, you put curious. I do not know. Why did you put curious?
Sir, because I am driven by my curiosity only, sir.
Okay.
I didn't know what I had to write. Sir, I am a alumni of CBIT, sir. So, according to generally when we write our top qualification. So, I do not want to, sir, because this is a session, this is a thing conducted by CBIT. I wanted to write CBIT, but first professionally if I have to write, I have to write BHL. If I have to write my qualification, I have to write my MTech Pits Pilani. I was in so much of thought. Then I thought, okay, these are not my identities anyway. So I am driven by my curiosity. So I wrote curiosity.
Fantastic explanation. Now, at this junction, I would like to appreciate, the entire CBIT management, because along with the teachers inspired you, right? That's very important. Inspiration is very, very important. And you never ever forget your alma mater.
Sir,
You might have done
sir, it is not inspiration, sir. Sir, if you don't mind, I would like to say this. Sir, I am nothing. Sir, I am a woman. First of all, I am working in a core sector, that too a PSU. And for a woman to work in a core technological field, and you have to give 10 times more in terms of not only especially your knowledge, sir. So whatever I have, and I'm telling you, sir, my identity or my professional experience, whatever I have, it's only because of my teachers and how they have encouraged me during my, and I think all my CBIT, like I am in touch with all my professors, and I remember each and every lecture which I have listened in my college time, sir. Because I'm in the core sector, and whatever I am working today, it is only because of my lecturers, sir, and it is because of my college, my foundation. And if I have to tell that I am an engineer, it is because of CBIT, my mechanical department, uh, and whatever I am, sir, it is because of them.
Wonderful, madam. Wonderful.
And I have a huge responsibility, sir, because they take so much of pride, and I have so much of responsibility towards not only my college, to the next generation students, to tell them that please trust your teachers, your professors, and you have a very bright future, especially in core sectors. And I am a very big example for that, sir. No, and I have seen now there are no core engineering takers, sir, especially mechanical, electrical, and all these things. And I'm telling you, please get the expertise. Please excel in your field. Money is going to come.
Wonderful,
Knowledge is
madam.
not.
Thank you very much. I think I have taken much time. Thank you very much. I congratulate you and as well as your teachers. Thank you
Thank you,
very
sir.
much.
Thank you so much.
Yeah, before vote of thanks is proposed by the Varaprasad, I just want to take few minutes of time to give a message. Sirisha, it was a wonderful, and I'm very proud that you are alumni of CBIT. And
Thank you, sir.
actually,
Thank
because
you.
this is the final day of FDP, then I was very worried about the last session. Because the
Yeah.
final like the
Yeah.
lasting impression is the best impression. So I thought, like, whatever the final session is, if someone who leaves the message or a session which will have a
I
strong
know
and
that. Last
positive
time we discussed.
impression, it
Yeah.
always be with the people, no? Like I thought, so really you have met beyond our expectations. So thank you so much. And
Thank you, ma'am.
really, like we'll be waiting for you because you are always help to us. Whenever I approached you, then beyond your capacity, you have helped all the time. So coming to this session, really it was very wonderful, and we are very much grateful to you. So over to you,
Yes.
Varaprasad.
Ma'am, I think I have missed some questions in the chat box, ma'am.
Okay,
I've
okay.
just opened.
Yeah, you can take up. You can take up.
Yeah, yeah. I think Dr. Neeraja has sent. Okay, when AI is getting inculcated into all areas, how do you feel a person can say he or she is an expert in a specific field? To what extent do you think this expertise can be maintained? Oh, madam, this is a very tricky question. Um, I think the expertise lies in interpreting, understanding, and comprehending what is happening and what is going to happen. So that is the whole crux of expertise now, ma'am. Especially in core fields, yes, there is a clear demarcation whether you're expert in a particular field. So the driving factor for any subject matter expert would be how are you deciphering or analyzing a particular problem or a particular solution, and how are you providing the solutions. With AI, actually, AI can give smarter solutions to all these things. So, for example, I have worked for more than 8 years in CFD. So, when a CFD problem comes, I can say I, it is very easier for me to interpret, not going through the whole process because it's a very time-consuming process. But seeing the result or what I can do, I can just tell. That's my expertise. Uh, and now with AI, all this Industry 4.0 or artificial intelligence, uh, the subject matter expert or the expertise of that person would be inculcating and adapting and working hands on with all these core technologies. And as already Sir told, reskilling, upskilling, and relearning and applying along with all these new technologies. I think that is where uh, uh, expertise, I think that's a new definition of expertise is going to uh, come in now, ma'am. Uh, I think I have answered that question. Yeah, I think no other questions, ma'am.
Yeah, ma'am. Ma'am, thank you very much. You were with the same energy, started at evening 5 and still the same even after 6:30.
Thank you, sir. Mechanical engineer, sir.
Yes, ma'am. It was a very uh, interesting and
Yes,
you have
of
put
course.
all your you have put all your experience and
Thank you, sir.
you have discussed with us skills for success and how the gap can be bridged. And apart from that, cultivating digital fluency beyond the basics and other many other topics, the power of lifelong learning ahead, and many such interesting points for discuss, madam. So hope this knowledge shared by you definitely transforms us through our journey in our academic career. Thank you very
Sure.
much, madam.
Thank you so much for a wonderful, for giving me this opportunity for a wonderful session, sir. And it's so nice and heartening to have a wonderful feedback from you all. Please feel free to connect to me. I would love to connect with all academia, and I would like to provide my assistance in whatever form needed. So I'm open to collaborate. I'm open to help. So, and I'm open to assist all of you. So please feel free to contact me. And thank you for being such kind and patient listening, for a patient listening. Thank you so much. And thank you, Saraswati Madam, for giving me a wonderful opportunity. And I think this is very, very special to me because this is for CBIT. Thank you. And I'm a proud CBITian. Thank you so
Thank you,
much.
Sirishma. Thank you.
Madam, over to you,
Srisa
Madam.
ma'am, may I come in,
Yes,
ma'am?
sir.
Only
Yes.
one few seconds. So I have shared my LinkedIn, link in chat box.
Okay, sir.
Okay, I would like to connect with you for support for my students
Okay, sir.
in BHEL. I
Okay.
was a coordinator for BHL for 7 years,
Okay.
between 2001 to 2007 in
Okay.
Tamil Nadu BHEL Trichy.
Okay, sir.
That is one of the biggest BHL in India. Right?
Yes, sir. Yes,
So
sir.
I would like to connect with you kindly, madam, please. Yeah.
Okay, sir.
Thank you.
Sure,
We
sir.
shall connect in LinkedIn.
Okay, sir. Sure.
Thank you. All the very best. Best wishes for your.
Thank you so much, sir. Thanks for the blessings.
Madam Saraswati, Madam, over to you.
Yeah. Thank you, Varaprasad.
Madam.
Good evening to all the participants. Now, this is a session where all the participants have been waiting since 6 days. And this session is assessment and feedback. So, as per the schedule, actually, we have from 6:30 to 7:30, wherein we have uploaded the assessment. So, please log in through your ID, participant ID, and you just look at the assessment and please submit the assessment, and as well as even the feedback is also available. And you please complete both assessment and as well as feedback, and you please stay on the platform itself. And once you have done, then we will just have a small valedictory session for half an hour, wherein we all together, because not just organizers but even the participants who were attending the session since 6 days, then definitely it is also a great effort where the participants have put in. So we will just conclude this FDP together, celebrating our collective efforts and whatever the learning which has taken place since previous week. So now I request all the participants to please log in and then just check the assessment and feedback, and we will be on the line on this platform. If you have any queries, then you please raise your queries so that we can rectify at the earliest. So please, all of you, be on the line and you complete your assessment and feedback, and we will begin the valedictory session at 7:30 and we will close by 8 o'clock. So thank you.
Thank you, ma'am. Point.
Madam,
Yeah,
Saraswati Madam, can I leave, ma'am?
yeah.
Thank you, ma'am. Thanks.
Yeah, thank you. Varaprasad, mute yourself.